So this is my solar system. I just installed recently. I only have one solar panel, 260 watt for the system. I just started with one solar panel, and this is in the Philippines. You can see here I have the charge controller, and the charge controller is where you have here connected to the solar panel and then back to the batteries. Here you could put, I think, a load, which I didn't really bother putting a load here. You could put maybe this light bulb, and you could use it like that. And here you can see the 12 volt battery. This is not the biggest battery, but this is the 120 amp hour, I guess, battery. It's big enough to start, I guess, to start this project. But in the Philippines, really, it's very hard to find stuff, especially in the province. They have very limited supply of batteries, very limited supply of equipments. So that's why I couldn't find a bigger battery. They usually sell bigger batteries, but the problem is they ran out of supplies, so I couldn't buy a bigger battery. And as you can see now, the battery is, this connection here goes to the solar controller, solar charger controller. And I do have a fuse here, just in case. And again, here in the Philippines, as you can see here in the Philippines, we're like everything, like there's nothing. You cannot find equipments. That's the problem. You can't find wires. You can't find connectors. So I had to do it like this way, like fuse them together manually. Like there's nothing. I couldn't find connectors to connect this. So that's the problem. So next time I'll have to bring everything with me from Canada, I guess, and bring them here. What else I'm gonna share? This is a 3000 watt inverter, and you have to connect the inverter. Let's see. It's giving me about 225 watt, 225 volts. Okay, that's how much is coming out from this inverter, 225 volts, which is what I need for the Philippines, I guess. That's the voltage they use in the Philippines. And then where I have this, then I have this unit. I buy this unit. I was thinking the automatic transfer switch, ATS. I was thinking like this is a really good unit that I need because I don't really live in this house. Like I only come here for vacation, so it's hard for me to use the solar panel, right? Without me being present here. So I needed to get a unit like this, but I didn't know how it works until I connected it. So now I actually regret buying it because this is not what I was looking for, right? The ATS, or the automatic transfer switch, this is, I think, made in US. I think so. I'm not really 100% sure. It's a very expensive unit as well. It's like 150 bucks. It's annoying. I don't like it. I really don't like it. I don't know. It's really bad design. Um, like you could see right now, for example, I have electricity from the main power. So we have electricity. We don't have blackout, but yet you could see the battery is supplying the power. It's not coming from the main line. The battery is supplying the power, even though I don't want to use my battery right now. I want to reserve my battery for a. I want to reserve my battery when I have a blackout, right? But this system really doesn't allow me to do that. It doesn't allow me to use my battery only when I have a blackout. This thing I didn't know about before. Before buying it, I didn't know. I just thought I could use something like this to switch to battery power when I have a blackout. It doesn't do that. This thing is useless. For that reason, it's useless. But I see where it's useful. I see where some people could use it. After I learned about how to use it, right? After reading the manual and everything. At first it was confusing, but now I know how it works. So basically, where it says here you have public power, this is goes to the main line. That's your city power, where it says public power. And the inverter was also quite confusing how to hook it up, because I thought initially you connect this part of the inverter from the battery to here, to the inverter part, right? But no, that's not how it works. The inverter is where the power is coming out from the inverter, and that will be from here, and the connection will go here, right? This is where the inverter is. It will have 225 volt going here, and then you also have 220 something volt from the city going here. Output is just as simple as that. It's the output is 225 volts. So the output is basically, it's either coming from here or it's coming from here, right? From the inverter, or it's coming from the public power. So basically this is a switch. It switches between inverter and automatically between inverter and public power. And the way it works, just think of it like this: a switch that will give you output either from either the inverter or the public power. And here we have a battery sensor. This is a battery sensor. This is like, well, I was confused because even in the manual it doesn't mention too much information. I thought this is where it feeds the battery into it. That's why I thought it supplies battery to the inverter. So I had the wrong connection initially, right? But I figured it out eventually. This is why I'm making this video for the future. So if I need to remove it, I know what it is. This doesn't supply any power to the inverter or anything. This is just a sensor, okay? It's a sensor, which means it measures the battery level. And when the battery level drops to a certain level, in the setting, you could change that. You could say, okay, I want it to, when the battery drops to 11 point, let's say 6 volt, I want to switch to city power. And that's what this sensor is for. And you could say also, when the battery charges to a certain level, let's say it charges to 13 volt, I want to switch to battery power. So that's how it works. It switches between city and battery power based on the voltage parameters you set for when it's fully charged or when the battery is empty. When it's fully charged, you want to use your battery. This is how it's designed. When it's designed like this. You set the parameters so that when the battery is fully charged, then you could use your batteries, right? And when the batteries are empty, you use the grid. This is what the system is useful for, but it's not useful for my case scenario, right? Because in my case scenario, I don't want to use the battery. I want to only use it during blackout, not all the time. This system is designed that yes, you're gonna use your battery all the time, regardless whether you have a city power or you don't have, whether you have a blackout or you don't have blackout, right? So it's designed like that. It's designed to use your battery all the time, regardless of whether you have city power or you don't have city power. This is useful for people who want to depend on the solar panels for their home, right? This system is useful if you are, this is useful if you are, like, let's say you want to save money on electricity and you want to use your solar panel as much as possible, right? In my case, no, I'm using my solar panel as a backup, not to save power, not to save on electricity bill. I'm using it for backup when I have blackout. So that's why this system is useless for this purpose. I need to have a different system. Maybe in the future I'll buy a different system, but for now it's too late. I'm already, my vacation is almost over, so I cannot really do much. The disadvantage of this, let's say it's using the battery right now, and when I have a blackout and the battery is empty, then I cannot use the system during a blackout. This is the stupidity of the system. I mean, they could have designed it in a way that allows you to have a setting where you could only use the battery when there is no power, no city power, but they didn't have that setting here. So that's the only way to use it, I guess. It's not a perfect system, but it's useful for other applications. But if you're looking for that, to use your battery as a backup, this is useless. Well, although I must mention that in the manual it says that you could use your battery as a backup. However, the only way to do it is that in the city power versus public power is that you have to have a lot of solar panels that you could use as your own grid, as your own power. Like, you have to have a lot of solar panels connected, and you could feed that as a city power, and then you have another set of solar panel maybe that you could use as backup. So the way it works is like, let's say you have two different solar systems, right? If you have two different solar systems, not necessarily it's different solar system, but like, let's say I have like 20 batteries, and all these 20 batteries are hooked up to a charger that charges, somehow you could charge them from the city power even, right? So like, let's say you have this system, you have 20 batteries, you hook them up to city power to charge, and then you could hook that system here, and that will be your public power, right? Or you could also have 20 batteries and solar panel charging them and hooked up here to public power, and that will be supplying your house with your daily needs, right? Whether you're running a fridge, the lights, or whatever, right? So it's like replacing the public power. You have a system that could replace the public power, you could hook it up here, right? I think this will be like either DC or AC, maybe. I'm assuming that because in the manual it shows you're hooking up batteries here. Although this is an AC, looks like AC switch. But I'm assuming you could probably use DC here as well, because that's how it is in the manual. It shows batteries are hooked up to the public power as well, not just the AC from the public power. So they have different set of configurations in the manual how you could use this unit. And one of the configurations is you hook up some batteries here, and then you hook up your backup batteries where the inverter is. So this is how you could use it as a backup. So if you already have a system that you could use as public power, you could hook it up here, and then you could hook up your backup batteries here. So backup batteries, let's say like you don't know, you have 20 batteries you could use for your daily need, but also you want to have a backup in case these 20 batteries run out. You want to have another additional 5-10 batteries on the side as a backup, right? So this is how you could use the system as well, right? You could hook up your backup here where the inverter is, and your public is where your main line or your solar system grid here, right? Eventually this is useless, like it's the same idea, it's useless. So what I'm trying to say here is that, yeah, you might be able to hook up DC instead of AC and use it as an automatic switch between two different two different DC sources, right? But then that's gonna be your own system. If like that is your own system, that's not public power. But it's really not much of a backup if you think of it, because like why would you have two different battery system configuration? Like it really, to me, it doesn't make sense, right? If you need more power, just hook everything up hook up all the batteries together, and that will give you more power. You don't need to have two different systems. Like in the manual it shows that like you could have two different systems. One is backup, one is and one is like, but I guess because it's assuming that maybe you're using wind power, so like you could have one system using wind power and one system using solar power, and you could make the two systems work together. Yes, maybe in that case, yes. So the solar system will be your backup, your wind power will be your backup, and then your solar system will be your main line, I guess. But it's kind of useless, I don't know, for some reason I think it's useless configuration. I wish they designed it in a way that will allow you to only use it when you have a blackout, but that's not the case. I have to buy another unit in the future, which is inconvenient, especially now I'm in the Philippines. I cannot find anything to replace this. Yeah, and that's pretty much it about my solar system. If you guys have questions, let me know and I will answer it. And by the way, if you're in the Philippines, these are the worst solar controllers. Don't buy them. Just buy it from Canada or US or wherever you're from, because these things, they burn out very quickly. I buy one and within a week I have to change it. Wow. Right, I have to change this unit. The screen was flashing and I don't know what the hell was wrong with it. And here in the Philippines, it's very hard to return anything. If you buy something, you keep it. Like you can't return it. So I have to go through a second solar controller to make the system work. It's a problem. Philippines is a problem. You cannot find anything easily. Like better you have a good charge controller. Like when you're buying a charge controller, also one thing to keep in mind is better to buy the higher amperage controller. Why? In case in the future you need to add more batteries, so it could handle more amperage, right? So choose something with higher amps. At least for me, at least a 60 amp. I have this is a 60 amp charge controller. You could go with higher if you want, but this is, I guess, the best size if you're planning to add some more solar panels in the future. 60 amps. And one more thing I didn't think about before installing the system is to have a fuse system, like to have a fuse added here to the charge controller to protect my batteries, right? I know I have one fuse here, but that one fuse is not enough. I want to have like a breaker. I didn't know that. You cannot use an AC breaker, by the way. You could use it, but it's not safe. AC breakers are not, from what I read online, it's not safe to use. So ideally what you want to have is a DC breaker. They sell them online. I'm probably gonna buy one. So these DC breakers, you could set them to shut off. They're probably programmable to shut off at certain amperage or certain voltage, and then you could turn them back on to reset. Well, they will be probably cheaper than the fuse, because the fuse is very hard to replace, especially if you don't live in the house. You cannot really replace them. You have to go back. I'd have to go from Canada to Philippines again to replace a fuse. This is not easy for me to do. I want to automate this house. Like, I want everything to be automated. Like, I will have something like a DC breaker that you could control online, right? That I could turn it on and off online. You could reset it online. This is the thing I want to have in the future here, right? So everything will be automated. I don't have to come back here to fix it. So that's one thing I'm gonna add in the future, and I will add another probably switch here from the inverter in case I wanna cut down the power, or because there are also breaker switches you could buy also that will monitor how much electricity your solar system is producing. It has a metering function. I'm not able to find online right now, like it's an AC breaker. There is AC breaker you could find online that has a metering function, works by Wi-Fi. You could control it through your phone, and that could measure how much output your solar system is giving you. And you could set it to turn off. Maybe that'll be a cheaper option for me, maybe in the future. Like, instead of replacing this unit, what I could do, I will just make two different switches, okay? So the way I'm probably gonna make it work, I'll have to do some experimentation here. So the way to fix this system here, a system that doesn't serve my needs, maybe is I put a switch here where the sensor is, right? If I put a switch where the sensor is, basically I will turn off the sensor. And if I turn off the sensor, I think this unit should maybe switch back to city power, right? So I'll have to find a Wi-Fi switch, preferably DC Wi-Fi switch that I could control by Wi-Fi, right? And I will set it up in a way that when the battery is fully charged, when it reaches to a certain voltage, the switch will turn off, right? So it will no longer allow this unit to switch to battery power. And then I will have to do something else, right? And then I'll have to do something else for the AC switch. I will have to put another Wi-Fi switch here, AC Wi-Fi switch, and the way it's gonna work is that I could turn off the power. I could control the power coming to the battery sensor. I could control the power going into the inverter. So this way, if it's accidentally chooses to use my inverter, my solar system, then I could turn it off and it will not work. It will not run from the inverter, right? It will not use up my batteries. So I have two different controls. With these two different controls, maybe I'll be able to turn it on when the power goes off, and so forth by Wi-Fi. So this way it's doable. But then with that kind of system, it's a lot of work. Better to invest in another system that will do automatically everything for me. Yeah, but it's good to have these two switches I'm talking about. Even if I choose to replace this system with another system, right? Anyways, that's that for this solar panel, solar automatic transfer switch.